Yeah, the question that before I started recording that I asked is, do you notice anything different about this particular proof from your other ones? Anybody notice anything a little different? Yeah. Yeah, there's just tons of stuff all over the place, isn't it? Don't you agree that it was pretty easy in your other examples to find out which two triangles you were trying to prove congruent? It was pretty straightforward, wasn't it? This one, not so much. Okay, this one we're going to have to kind of look at things and say, well, what's my best choice here? Okay, there really is just one way you can officially do it, okay, based on the knowledge that you have. Anything else you notice that's different about this one from the other ones? Yeah. Yeah, that's a little different. It's saying prove the triangle ABC is isosceles. Again, does this one say anything about proving triangles congruent? Nope, not a thing. But guess what? It's in this chapter. What are you going to try and do? Prove some triangles congruent, but it's really hard to figure out which ones. Because I see a lot of triangles. I don't know about you, but I see a lot of potentials here, correct? Do you agree that it could possibly be I have to prove that that triangle is congruent to that one? You agree that has a shot, right? It's a potential one, right? Or it could be that I have to prove that triangle congruent. I better do a different color, seeing they're crossing each other. Congruent to that one. Right? Do you agree the green and the red have a shot? Except for obviously that one red's kind of very confusing. But I actually see another pair that have a shot. Well, that didn't work very well. Anybody else see two other possibles? Yeah. Okay, so yeah, she says BEA and CDA. Wow. How are we going to figure out which ones we're supposed to use? This is like a maze. Okay. Well, I think there's an obvious choice just by looking at those, which one we should use. But let's go put the given in, and we'll just work through it. We'll see what happens. Okay? So AD is congruent, and that's even difficult, right? AD is congruent to AE. The only reason I'm doing that is so that I know it's not the whole thing. Because you agree if you put that congruent mark in, you might think it's all the way from A to B. All right? So we got to be very careful what we are actually saying is congruent. And if you're not good at the little curly Q things, just put a little arc in there or something. All right? This isn't, you know, an art show. And we know that ACD, just that itty bitty one right there, is congruent to ABE. Right? Notice I didn't do the whole angle because we don't know that. Let's face it, if we did know it was that whole angle, we'd be done because that's the base angles of the isosceles triangle, so we'd know that. Wow. That looks very symmetric, but not very helpful. Well, you don't have to write all this down. You can just follow along. I think it'd be just as helpful if you just follow along. What was the first ones we said? It was these two, right? These were the first two we said had a possibility of being congruent, right? So I'm just going to draw them down here. Again, you don't have to do that. And so in that, we have basically this one congruent to that one, right? And some letter I don't know in the middle, right? Right there, I don't even know what that is. D, B. Do we know anything else about, well, I just drew that horribly, but. Do we know anything else about those two triangles? Now that I've drawn it a little better, maybe now you can see it. Do you agree we also know that that would be congruent to that, right? Do we have enough knowledge about those two triangles to prove them congruent? We have angle, angle. Do we have enough? Nope. So do you think those two in green are the ones we're going to try and prove congruent? Probably not. Okay. Awesome. Well, let's erase that then. Again, this is stuff you don't have to write. You can just follow along for now. All right. I put the right angles, didn't I? Yeah. Okay. What was another option we had? It was that and that. Do you agree? That was another potential. Well, I'm just going to draw those for you then. D, B, C. C, E, B. What do we know about those? We know that they're blue now. That's what we know about those two triangles. Because you agree that this little red angle here by the B is only for that little top portion, not the whole thing, right? So we know absolutely nothing about those two blue triangles that I just drew. So I'm guessing we can't prove those congruent. Yep, not gonna work. All right. So that leaves us with the last one. And it's a coincidence how I chose the last one to be the one that actually worked. Just an amazing coincidence, isn't it? All right. So it's that one. And that one, correct? Yeah, I gotta make these smaller. But they're not gonna fit over there, are they? So the blue one goes from A to E over to B. A, E, B. Got it. And the black one, and it's gonna be in the way anyways, is A, D, C. And I know that, and that, and that, and that. Agreed? So let's face it, this is almost the most that we've been given so far, right? We've been given 2 out of the 3. Now I told you this works. That's why I saved it for the last option. How does that work? Yeah. Yeah, isn't angle A the same angle A in both of them? And am I okay just saying angle A here? Are you all going to be looking at the same angle if I just say that? Yeah. So that, very good, is congruent to itself. That's excellent. And to your amazement, it's actually angle, angle, side, the one we just learned, right? To your complete amazement. Does everybody see the angle, angle, side? Okay. Well, let's get going here then. Number 1. AD is congruent to AE. And angle ACD is congruent to angle AB. And our reason, given. Missed one. Still missed it. Got it. Oh, bummer. Well, why did I get that whole thing? Well, we'll try one more time, and if not, we'll just be done. Okay, so here's what we're going to do. Oh, well, forget it. That triangle is staying right there. All right, I'm just going to write over the top of it in blue. Okay, so of our angle, angle, side. Well, let's look down at these. Do you agree that looking down at these two is way easier than looking at that big thing? Right? So let's just look down here at the black one that's really reluctant to move and the blue one. AD congruent to AE. Is that something I'm actually using in my angle, angle, side? That's actually getting used, isn't it? So cross it off. Done. Another thing here is that angle ACD, right there, is congruent to AB. Is that also something I'm actually using in the angle, angle, side? It is. So cross that one off. And it doesn't matter which one, right? Which leaves us with only the other angle, which we've already been told why that's congruent, right? Basically, what we have to say then is that angle A, and is it okay, again, I just asked you, is it okay just to say angle A here? Yeah, it's congruent. Angle A. I actually am very lenient on this one. I accept 2 answers on that particular one. Depends on how you look at that. Anybody want to give an idea on a reason for that one? I actually accept 2. I probably shouldn't, but I do. Yeah. Yeah, reflexive property is good. Something congruent to itself, right? Same thing with the segments. So reflexive is good. Okay. Oh, property. I, in a very nice way, also accept symmetric, but that's probably shouldn't. All right. Whoa, wait a minute. You're out of here. So, hey, we just crossed them off. prove some triangles congruent. And now we even know which ones, right? ADC, I'm going to put. Congruent to, so if I went ADC, I better be careful here. If I went A, it'd be A to what, E to B? Is that right? So 3, again, sorry for writing over the top of that, but it just didn't want to move. Angle, angle, side. Well, once we figured out which triangles we had to prove congruent, this wasn't that hard, was it? Yeah, here comes the hard part. I still haven't done what they wanted me to prove. And this took the other period quite a while to come to this conclusion, but somebody eventually did. Yes? Exactly. Because now that I've proved it congruent, I can come over here and just go all over the place, right? I mean, this is done. We know these are all the same now. You can just go like this, go like that, go like that. But you have to find out which ones do I even care about. And that's when you have to go back to the original. And they figured it out perfectly. Of all of these, DC is just this segment, right? I'm looking at this first triangle. Does that help me prove an isosceles? No. Another one's AD. Does that help me prove an isosceles? No. The other one in this black, very stubborn triangle is AC. Does that possibly help isosceles? You bet it does. And the one that matches up in this blue triangle down here is AB. And do I know those two are the same now? I do. But I had to pull that information out. That's perfect. So AB congruent to, is it AC, right? That's the way you should go? Yep. AC. What's our reason for that? Say it. Yeah, somebody wants to say that. CP, CTC, yeah. Because once you prove them, these triangles congruent, you can go put all those markings and see what matches up. You're good to go. But wait a minute. My last statement should really be that. And I haven't stated that yet. But can I now? I can. I can say that triangle ABC at a very minimum is isosceles, right? Based on what isosceles means. And so what would be my reason? Considering what I just said, what would be my reason for 5? Yeah. You could put that because AB is congruent to AC. Sometimes what I like to do is really spell it out. Definition of isosceles. That's what it means, right? 2 or more. Okay, so I'll be very honest with you, though. I will never ask you to reproduce one quite this difficult on a test or something like that. If you understood the proofs that you did for today and the ones we did yesterday, if you kind of understood how those worked, you'll be fine on any kind of test or a quiz. Okay? So don't worry about something like this. Remember, you got that one for extra credit, so try that one. Great job. Way better than the other bunch. It took them quite a while to get that. Yeah. All right, how about this one? Here's triangle ABC and DEF. Can you determine if they are congruent? I hear yeses, I hear no's. I see shaking of no's. See, everybody thinks it's going to be which one? Everybody thinks it's going to be angle, angle, side, right? Because that's what we're doing today. But that's not what this one is it? Yeah, this is the unfortunate, right? The side angle, right? So you can't just jump wherever you want. It is still side angle, and so this is a big no, I cannot. Some people say, but that's a right angle there by angle F. I'm like, it doesn't say that. Does it look like one? Yeah. And is it probably, if I sat there and measured that one, it probably is. Okay, but we're saying without protractors, without tools, is it? Just look at the information, and I don't know. I can't tell. Okay. And then this one. Angle 1 and angle 5 are right here and there. And do you agree 1 and 5 are both part of that black triangle, right? That I just traced. And for included side, that kind of means the side that connects them or puts them together. Like when we talk about angle, side, angle, that side's the included side. It has to be the one in between them. So if we look at this example, we have to look at the black triangle we just have, and we have 1 and 5, so the included side has to be that one right there, which is DC. Do you see how C is kind of, I don't know, the computer was not cooperating that day. So it would be DC. Is it okay in this case to put CD? Is it acceptable? Yeah, because we're not talking about what? Yeah, we're not talking about congruence, right? We're not talking about congruent triangles. We're not talking about, we're just saying it's a segment. Where is it? What's its name? DC. Number 2 has a lot of answers, and I'm going to narrow it down for you, though, because that's really what they want. It's just the book asks the questions the same way, but they're very vague about it. And so we're going to say DE. Where's that? Right here? And once again, I'd say that DE is kind of part of that same triangle we were looking at before, right? Or it could be part of this bigger one, right? But let's just say, let's narrow it down to that triangle. Because let's face it, if I had to pick angles where DE is not included, could I say 8 and 9? You see, that really doesn't help you learn what we're talking about here, right? So I hope you agree that 12 and 5 are kind of make DE the included side, right? So that's not what they want. So in that triangle, there's actually 2 ways you could say that it's not included. I could choose 1 and pair it with 12, agreed? If I use 1 and 12, which side's the included one? It's EC, right? And if I choose 1 and 5, it's actually CD, right? So I could choose either 1 and 5 or 1 and 12. It doesn't matter. Either one of those pairings makes DE the non-included side, right? Or a non-included side. You don't have to give both. I just wanted you to see that. Any questions on that one? That's kind of a weird one, especially the way they word it too. Okay. All right. Okay, if 6 is congruent to 10, okay, 10 and 6, DC and VC, then triangle DCA, where's that, up top there, is congruent to which other triangle? Was it congruent to any of them? Which one's probably the best chance? VCE has the best chance, right? So let's just trace that one and see if we can figure it out. VCE has the best chance. Here we have an angle and a side. Same thing up in that red one, an angle and a side. Do we have enough other information? Yes. Yes, it does start with a V. Vertical. Which ones are vertical? 2 and 4. Very good. 2 and, well, so are 1 and 3, right? But they don't help us in this case, right? 2 and 4 are vertical, so then can I actually prove VCE is the congruent triangle? I actually can. It's VCE by what, though? Angle, side, angle, yep. Come on now. All right, last one. 7 and 11. Where's that? There you go. 11, 7. AD, where's that? Top. ED, bottom. And DC, didn't I just have that one on there? And VC. Can ADC, well, I kind of could have just kept the same stuff I had on there. Is that one congruent to that one? Based on that information. Yeah, I just did a whole lot of erasing, and I could have left most of it on there. Yeah, I guess so. It knew. Yeah, the smartboard knew and was smarter than me. Can I prove those 2 triangles congruent? Yeah. Yeah. Right. The key here, I was trying to trick you. I was trying to show you side-side angle and see if you would just say no. But aren't 2 and 4 still vertical like they were, what, 10 seconds? Well, actually about 20 seconds ago because it took me so long to erase, right? But they're still congruent, aren't they? That's something you know. So now we have 4 bits of information for each one. Does that increase our likelihood of them being congruent? It does, because then you only need 3, right? And can I make one of them happen? I actually can. I can make the new one happen. Angle, angle, side. Is there still side, side, angle up here? That one doesn't tell me anything. But angle, angle, side tells me we're good. So was I trying to trick you? Yes, I was. But you didn't let it happen. So very good. So are they congruent? Yes. Angle, angle, side. Okay, very good. Any questions on what you've seen today? So now you know 4 that work, 2 that don't.